solve three-factor mapping from the table that we saw in one of our homework assignments. Determining the NCO, SCO, DCO, and then determining the gene order and distance in map units. So I highlighted right here in gray, this is our given. This is the given information in our homework assignment. As you can see, it's hetero, since for size that we labeled A is both negative and positive. The same goes for movement, and the same goes for the loci. Instead of T and A, we use G and C. In blue, we highlighted, the analysis we highlighted in blue. So this is what we these are the parentals, by the way. Ignore this, F1 and F2. But the blue, this is what we analyzed based off of the given information. So if there's a hetero parent, they're most of the time, I don't want to use the word always, but most of the time crossed with the homozygous parent. So that's why we put size as negative, movement as negative, as well as the G loci as negative. For anyone that got confused between T and A on the homework, I want to say me and Jenny, but mostly me, I just wrote next to it that if it says mutant information, just put it as negative, and the other one is normal, positive. So just make it a little easier in determining the gene in the middle. So this is the table that we just copied from the homework, but we wanted to make it a little more simple to understand. So the first step you want to do is determine the non-crossover and the double crossover. Non-crossover is going to have the most observed, and the double crossover is more rare, so we'll see the least observed. In green, you'll notice that is what we identified as the non-crossover, and in purple looks kind of black, but it's the double crossovers. And then I just wrote single crossover 1 and 2 just to organize it more. Once you look at that information, fast forward, and you can compare everything to each other, and that's when we can start determining the gene order. So for the sake of time, I didn't write everything out, but you want to compare the parental, the non-crossover to the double crossover in order to find out which gene is going to be in the middle. So when you write out just the non-crossover and the double crossover, which is small, uncoordinated, G loci, which is the mutant, negative. Another one which is small, normal, G and C. If it has G and C, we interpreted that as positive, since the normal is going to be.
The C will be expressed because it'll be dominant. The mutant is typically not going to be expressed in the presence of C in this case, so that's what she's trying to explain.
It's also on the F1 genotype that you have up there.
Yes. So after looking through that, once you compare, I wrote it out. I don't think I circled the right one. Back. Well, actually, yes I did. You want to compare which gene is different. So in this case, I highlighted in green to make it easier for comparison. So you'll see 3 positives on the bottom, which that stands for, small, Yeah, the ones that are positive are just the normal. And the ones that are just in letters are going to be negative. I even wrote negative next to the G. You notice that the A gene, which is for size, they're in different spots. Different alleles.
Okay, so in terms of gene order, once you've determined which one is in the middle, you're going to, are you still on the first one? Yeah. So when looking at the NCO and the DCO together, you're going to look for the allele that's different out of the combination between the two. So in looking at the parental, you see that you have a positive, because it's a heterozygous, which is what the parents are, and then you have a negative. But then when you look at the double crossovers, you're gonna have an allele that's different. So instead of having positive, 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 negative, 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 you're gonna have one that's switched, typically. So in this case, it's gonna be, is it A?
Yeah.
Did you do the same one? Yeah. So this one, it should be, yeah, it should be flipped, but that's why I was confused. So then from there, you're able to, once you've established that, just for the sake of this, instead of looking at this, you see the circles, let's just say that this allele is different from the parent. You know that one's in the middle. So then from there, and using the other information that is provided from that actual question, the 3 MU, the S&P is 3 MAC units away from, or to the right of one of the other genes. So then from that, you can go ahead and wage, once you're looking at your single crossovers, that, oh Lord. I'm so
Jenny,
sorry.
you're doing it. There's just one minor thing on the flip side. Your second line that's green you've got small for the first one, and the second one needs to be normal.
This part?
Yeah, that one needs to be normal as well. That's the, yeah. But that's the only thing that I'm seeing,
Right here, right?
yeah. Normal,
Yes.
yeah. So you found the one that's in the middle.
So then from there, if you're looking at SCO1, you have a small normal, and then a G, which is negative. So you have a negative, negative, positive for that one portion. And then for the other SCO1, you've got a normal, which is positive, negative, and positive. So your difference is going to be within the normal and uncoordinated. So your movement's going to be your B allele, or gene. And then from there, you go to SCO2. And since
So what does
this-
that tell you then about the crossover? Where did it occur?
For me, the
If
way
B
that
is
I
different.
learned it, or like the way that I understood it, I mean, given with the information, it was easy to kind of go ahead and put it in order, because in our case, from that question, it was 3 MU to the right of B, which was UNC 23, I believe, in that question. So we were able to tell that that one was in front. So that one was before, and then the middle one, since we had already determined, was the SMA 12 in that question.
Great, which is A here.
Right, which is
Okay.
A here.
Okay.
So we know that, can I see this marker? Right here, oh, she already got it. So we were able to figure out that B is first, because here is
The
the
middle.
one we figured out was in the middle, and that would mean that the G/C loci was on the right.
Very good.
And then from there, when you do your recombination frequency, you're taking the total amount between, well, this frequency right here is not between the whole thing, but since you know that this entire thing right here is 3 math units apart, you take the total of each pair of alleles that you tested against in order to figure out, so between B and A, and then A and GC loci. So between B and A, it's going to be 1%, and then between A and GC is going to be 2.
So, yeah, you just walked us through the single crossover events that occurred after B and
Yes.
before, between B and A. Okay, and the other one, you can show that it was between A and the GC.
Which is, gonna be 18. I can't do math in my head. Plus 2. Equals 2. Sorry that this was scattered. I'm really not good at coming up with anything on the spot. I'm even worse at explaining things in front of people, so.